which is a popular project, as well as giving students an experience with the different disciplines of engineering. It's really great because it's very customizable. And it has a mind of its own. It's kind of interesting. Her modifications I thought were really creative and cool. She's going to show them to you now.
Fine enough. Okay, so hi, I'm Kaizena, and I'm a rising senior at Galileo High School. My starter project was a mini POV, and my main project is, yet again, the omnidirectional robot. I chose to do it because it's what first caught my interest in BlueStamp when I saw a demo for the program. And it also seemed like something that would give me an all-around experience in engineering, considering I didn't have any experience at all beforehand. And here, behold, omnidirectional. And then the ultrasonic sensors. So it works by using an Arduino again, which is the programmable microcontroller chip. It's connected to the receiver for the PS2 controller, so that when the controller sends a signal, the Arduino will be able to tell the motors to move. The motors, along with the sensors and the battery, are connected to the Arduino through a perf board, which is a board that lets me solder in the wires and the parts in permanently, so nothing falls out. The battery that powers the Arduino is 7.4 volts, and through the Arduino, the receiver and the sensors are also powered. The motors, they also use the battery to get power instead of the Arduino, because the Arduino can't handle the current that's needed to power the motors. Coding-wise, trigonometry, not easy on me because pre-cal is not for summer. But yeah, the hardest challenge would be when the robot started glitching out and moved, even if I wasn't touching the controls. I found that it was because the receiver for the controller would disconnect and reconnect, and every single time it reconnected, it would send a signal through the analog stick, and since the analog stick is what controls the bot, it moves. So to fix that, we made it so in order for the analog stick to actually move the robot, another button would also be pressed, and then, yeah, it was fixed. But that wasn't the only thing that caused it to glitch out. The time it glitched out the most, it had the most anticlimactic solution ever. I needed to charge its batteries. But yeah, glitching out is, I think, the most common problem for the omnidirectional robots. My modification, as you saw before, was the ultrasonic sensor. I put those on because I also plan to have a second layer on top, because I wanted my robot to carry things around, but then I didn't want the robot to crash and break like a lot of stuff at home does. So now, whenever there's an obstacle within a certain distance of the sensors, it'll move backwards. It's off right now, so yeah. Why I joined BlueStamp? Well, I use a computer every day and other machines every day, but I didn't know how any of it worked, which I thought was kind of pitiful. So there's that. Also, I had no idea what I wanted to do in the future, and I wanted to see if engineering was the thing for me. Now that the program's almost over, I know I'm definitely interested, not 100% sure yet, but getting there. I've learned a lot. Google's now even more of my best friend, and yeah.
So you mentioned how you were going to have your robot carrying something.
What's wrong and how to fix it?
Well, my idea is normally to beat my head against the wall, trying to fix the problem, and then once I come to a complete dead stop, I just figure, why don't we just replace everything? I think one of the biggest things I've learned in this program is that replacing things is completely unnecessary, and there's usually a way to fix it. The most recent example was when somebody so kindly unscrewed my servo mount as a prank. And when I screwed it back in, it was very wobbly and it wouldn't mount very quickly. So my idea was like, oh, do we have enough filament left to 3D print a new mount? I have a mount right there. And then we tried a few things like different screws until it took like 20 minutes until Nathan suggested, why don't you just put hot glue in the holes? I thought I completely misrepresented it and filled in the holes before I put the screws in, thinking, oh, so I'm going to have more stuff to screw in. That worked, but it was not as effective as what his original idea would have been, which is to screw it in and then hot glue.
You should have dressed like Link to sell the idea.
What?
You should have dressed like Link to sell the idea.
I wish I had a snarky comment to return, I'm sorry.
As someone who's also somewhat interested in electrical engineering,
Yes.
how'd you figure out the LEDs run backwards?
Well, we used, what's that big machine called that we first used?
You mean the oscilloscope?
Yeah, the oscilloscope. We used that, and for some reason we still couldn't figure it out until like a couple days later. I was still trying to figure out why it wasn't working, and then Nathan had the brilliant idea of using a multimeter on it, which really should have been our first go-to. And in all 5 seconds figured out it was on backwards. That was a week of my time that I couldn't figure out. I put it on backwards.